Hello everyone. Let me ask you, why don't lakes and rivers freeze solid from the bottom up during winter? If they did, all aquatic life would perish every year. The answer lies in the consequences of anomalous expansion of water. As we've learned, water expands instead of contracting when cooled from 4 degrees Celsius down to 0. This unusual behavior may sound like a small detail, but it has some of the most profound effects on life and the environment. Let's explore them step by step. Imagine a lake cooling down during winter. As water cools, the heaviest water at 4 degrees Celsius sinks to the bottom. Water colder than that, say at 2 degrees or even 0 degrees, becomes lighter and floats at the surface. Eventually, the surface freezes, forming a thin ice sheet. The deeper layers, however, remain liquid at around 4 degrees Celsius. As shown in the diagram, this top layer of ice acts as insulation, protecting the water below from freezing. That's why lakes and ponds freeze from the top down, never from the bottom up. Now think about fish, plants, and tiny organisms living in these lakes. Thanks to the insulating ice on top, the water at the bottom remains at 4 degrees Celsius, the perfect temperature for aquatic life to survive. Without this anomaly, entire lakes would freeze solid in severe winters, destroying ecosystems each year. But nature has designed water with this quirk, so life continues beneath the frozen surface, even in the harshest climates. This is one of the most direct and life-saving consequences of anomalous expansion. But the story doesn't stop with lakes. The anomalous expansion of water also shapes rocks, rivers, and even climate. When water seeps into cracks in rocks and freezes, its expansion breaks the rock apart, a process called frost weathering. Icebergs floating in oceans affect salinity and currents, influencing global climate. And because ice reflects sunlight, what scientists call the albedo effect, it helps regulate Earth's temperature. Seasonal freezing and thawing cycles of rivers also carve landscapes over thousands of years. So, a tiny anomaly in water's behavior helps sculpt both local geology and global climate. Now, let's see some human-scale consequences. In cold countries, water pipes often burst in winter because water expands when freezing inside them, exerting enormous pressure. Dams and reservoirs face stresses from expanding ice layers. Roads develop cracks when water inside crevices freezes and expands. On the useful side, cold storage systems sometimes exploit water's expansion during freezing for regulation. So, anomalous expansion is a double-edged sword, sometimes destructive, sometimes useful, but always powerful. Let's work through a numerical example to see how even a small change in density produces significant effects. Suppose we have 1 kilogram of water, which is 1000 grams. At 4 degrees Celsius, its density is 1 gram per cubic centimeter, so its volume is 1000 cubic centimeters. At 0 degrees Celsius, the density drops slightly to 0.9998 grams per cubic centimeter. Using the formula density equals mass divided by volume, we substitute 0.9998 equals 1000 divided by volume. Solving, we find volume equals 1000.2 cubic centimeters. That's an increase of just 0.2 cubic centimeters. It seems tiny, but across large lakes and rivers, this fractional change becomes enormous, enough to split rocks, burst pipes, or shape entire landscapes. So let's wrap this up. Water's anomalous expansion means that as it cools below 4 degrees Celsius, it expands instead of contracting. Because of this, lakes and ponds freeze from the top down, insulating the water below and ensuring aquatic life survives. It also shapes geology through frost weathering, influences climate through floating ice and sunlight reflection, and affects human structures like dams, pipes, and roads. In short, without this anomaly, Earth's ecosystems, climates, and even our day-to-day environment would look very different. I hope you now appreciate why a simple property of water, its anomalous expansion, is one of the cornerstones of life on Earth. See you in the next session with another exciting journey into the world of heat and energy.